Welcome to the latest edition of Chatting with Chuck. I'm your host, Chuck. Today I'm talking about machine vision. Recently, I've seen many articles on machine vision and how it's taken large strides in the last few years. I thought I would check this out. What I found is machine vision has evolved rapidly over the last several decades. Fast, high-resolution digital image capturing, ample PC processing power, and image handling software have all combined to achieve these useful systems. Even when systems in the 1980s were capable of recognizing labels and two-dimensional symbols, there remained significant challenges. The objects being inspected often had to be carefully aligned to present a repeatable image, and lighting had to be almost near perfect. Early generations of software were complicated to configure and limited in their capabilities. However, these limitations were overcome. Machine vision could excel in high-speed inspection applications. Machine vision provides the ideal solution for this form of inspection work and can maintain a photo record of quality purposes. The latest smart camera systems offers even more advanced capabilities such as 3D. In these cases, machine vision offers options no other sensing technology can provide, such as computing the volume of an inspected target. While 2D imaging has been the established technology for many years, advances in 3D imaging will be supplementing and even superseding 2D. In addition, vision platform advances and cost declines are opening up machine vision technology to complement other fields, especially robotics. Clearly, machine vision systems offer many superb advantages. While image processing and computing capabilities will continue to increase, there remain many challenges for typical end users wishing to develop these systems. So what are these challenges? Let's discuss those. And I see a few here. First, I think they're expensive to acquire, hard to integrate with other automation components, performance limitations in the terms of speed and object recognition. They're difficult to program, they're not scalable, and they're hard to engineer, maintain, and even modify. So industrial automation hardware such as controllers and sensors never comes cheaply. Even though some components are less expensive than others, devices used for industrial automation sell far fewer quantities than common consumer goods and must be built to operate for many years in harsh environments, and both facts drive up the prices. However, even within the realm of industrial automation, machine vision has been somewhat of a specialty. Machine vision components have traditionally been relatively expensive and many times have required a high level of pre-engineering to specify. The installations demanded careful attention to orientations and lighting. Vision systems could be very effective, but there are no shortcuts to achieving functionality. As with other specialty analytic sensing systems, vendors concentrated first and foremost upon the sensing technology. Even when a properly engineered and functioning system, the primary focus of a vision platform was more on the vision functionality and less on the integration with other systems. Communication interfaces were still evolving, and oftentimes vision systems were installed as standalone islands, performing their function exclusive on other automation in the area. Until recent years, performance was always a concern. There was not always enough image resolution and processing power to adequately recognize objects with the desired speed. Even when end users could obtain the right hardware and install it as needed, the next hurdle could even be a larger one: how to effectively program the machine vision system. These specialty systems were stretching the hardware to the limits, and the accompanying software was often complicated, cryptic, and difficult to learn. Many vision systems over the years have been bolted into place and then experimented with for a time, before being abandoned or perhaps superseded with simpler, but therefore less capable sensing methods. Available hardware options were typically quite limited. Users often faced making their application fit the capabilities of the vision system instead of the other way around. With the hardware and software already running at maximum capability, there was no way for vendors to offer the platforms in a scalable manner. The lack of modular options limited the choices for end users and increased cost. These challenges often combine to push determined end users into retaining specialty engineering and integration firms to implement vision systems in their plants and facilities. Certainly, there's nothing wrong with relying on trained experience. However, given the experimental nature of many early vision system endeavors, the added cost of expert talent deterred many users. Also, the ongoing obligation to use a dedicated engineering firm for changes or even basic maintenance was cost prohibitive in many cases. The first generations of industrial vision systems held a lot of promise and were adopted to great effect by many cutting-edge end users, but the expense, limitations, and difficulty of programming and maintaining these systems often defeated many projects. For machine vision systems to become truly mainstream, they would need to become easier to use and more powerful, as well as more economical. Some of the required hardware and software improvements for end users would include making the hardware scalable and the software easy to implement. So what are the machine vision platforms? Well, fortunately, several advances in the consumer computing arena have supercharged exactly the technologies required for widespread adoption of industrial machine vision. A few of the key technologies which have progressed in this way over the last decade or so include proliferation of high-resolution digital imagery hardware, development of extremely powerful PC and graphic processors, software design with an increasing focus on both flexibility and ease of use, exponential growth of high-speed technology or networking and large capacity storage, and standardized protocols. Taken together, these advances truly bring machine vision into the mainstream of automation technologies. They allow users to focus on solving problems and improving operations with vision platforms instead of worrying about how to make the technologies work. Recently, in Control Design magazine, or I should say on their controldesign.com site, there was an article that broke vision into three-part system. They were processor, sensor, lighting/lensing, program/interface. Just like a three-legged stool. If one of the legs is weak, the whole thing can falter. These three parts could also be loosely defined as hardware, installation, and software. Let's talk about the standards for implementation. Simply, the standards, I guess is the best way to put it. Standards usually play an important role when selecting any industrial automation system, and machine vision platforms are no different. There are two prevailing standards to look at, GigaVision and GenICam. Gigi is a set of protocols built on the top of a standard gigabit Ethernet, optimized to supply the image data and interface with any camera parameters. GenICam is a standardized application program interface ensuring a common software experience for users with regards to interfacing with machine vision cameras. Machine vision platforms should offer programming software that strikes the right between the ease of use for users to learn and configure and sufficient power to implement all future needs. Configurability is important not only when the project is first installed, but also as users must maintain and even modify or upgrade the system in the future. So what are the machine vision benefits? End users need to improve quality to reduce costs at all levels, and machine vision systems are well suited to achieving this goal. The performance and features of today's machine vision systems have advanced to make them a fit for more applications than ever. But perhaps the biggest improvement is due to the solution-ready platforms, which are easier to install. While we have focused heavily on industrial factory applications, accessibility machine vision systems is opening up their use in many other industries. Most vehicles use some form of machine vision, and development on soft robots, which can work side by side with humans, also relies on vision sensing. Machine vision is even posed to transform the basic human endeavor of agriculture. Forbes.com reports how mobile field robots may visually inspect the progress of crops, eventually performing physical tasks like pruning. Fleets of vision-equipped harvesting equipment are not far away. Contemporary machine vision hardware and software can rapidly be deployed leveraging commercial technologies such as Ethernet. Powerful options mean most any need can be met, while simplifying configuration options greatly improve the likelihood of a successful result. The very same features making a modern machine vision system functionally effective also make it more cost-effective initially, and later in the life cycle when modifications and maintenance are required. Looking to the future, the best platforms offer useful scalability and flexible growth options. So, what does all this mean? Let's talk a little bit about conclusion and the little bit of an outlook here. Machine vision is in no means a new technology, but extensive hardware and software improvements over recent years have greatly increased the usability of this powerful sensing method. Properly maintained, machine vision can operate at an exceptionally high speeds to inspect production at extremely high levels of detail, offering end users a way to achieve the highest possible quality. And along with this increasing power, many recent enhancements have been aimed at making vision systems more accessible for end users. Scalable and modular hardware components based on dominant mass market technologies and optimized protocols enable the underlying hardware to have more than enough capabilities. Software has been improved not just by adding more features and computational capabilities, but by applying a focus on flexibility and ease of use. Machine vision systems are moving from a specialty niche sensing technology to a common automation application. Users are now positioned to self-perform this type of work if they choose and can realize savings over the life of the equipment. Taking together, the latest scalable machine vision hardware and software platforms ideally positioned to help consumers solve the automation challenges. So I know that was a lot to talk about. I kind of put it all in a bunch of words from many different sources. And I hope that gave you just a few minutes of what I found on machine vision. I know there's a lot more out there on this. I just found it as an interesting topic and I wanted to talk about it for a few minutes. So I hope once again that this might have been helpful for you. As always, this is Chuck and this has been Chatting with Chuck. I hope you enjoy and stay tuned for further episodes.